Next presenter is Rolandos, and he will be giving a talk about scaling 3D sign language dataset, Markerless hand caption in the wild.
Thank you very much. So I'm not going to speak about sign language modeling directly, but rather how we can create data for 3D sign language generation. So our models were presented today from our postdoc Ronglai. So our motivation here was that 2 years ago we tried to tackle the problem of 3D sign language generation. And we realized that we cannot generate sign language, we cannot do sign language production because we didn't have 3D data. And of course, the question is how we can capture sign language data in 3D. Well, I guess the most straightforward solution would be to set up capturing systems or use mock-up data that can give us the 3D information of the signer. But of course, this is not very scalable and it's very expensive, not only to acquire such systems, but also to annotate them and get those information. So what we would like ideally to have is systems that can automatically give us this 3D information in the wild. So we can go directly to videos that we have plethora of signing videos and get this information in 3D. So this has several challenges. And the main challenge, which is also my main research, is the hand poses. So in order to reconstruct accurate hand poses, we need very accurate hand detectors. And surprisingly, this was actually the main limitation in the literature so far, how we can have reliable hand detections. So many of you talked in the previous sessions about Google Media Pipe, but apparently Google Media Pipe has very poor detections. And you can see in this image with having 10 hands, Google Media Pipe can only detect 3 of them. And it's also very, very slow. So all of the previous methods for hand detection were extremely slow. So considering combine this with a 3D hand pose estimation method, then the whole pipeline will be extremely, extremely slow, and we cannot scale on the data side. And finally, they are very unreliable. They have a lot of false positive rates. So in this image, Google Media Pipe does not detect any of the hands in this image, but actually detects a hand in a place that it doesn't exist. Now, in terms of the actual 3D hand pose estimation problem, this has also challenges. There have been many works that have done great progress, but still they are usually trained and evaluated in the same dataset. So they have this similar distribution. So when we are going in more in the wild data, we have some failure cases because they don't have those large-scale priors. And they also lack this accurate image alignment. So when we reproject the hand in the 2D image, we get this misaligned version of the hand. So to solve those two issues, what we did is we collected a lot of videos from open source datasets, and we detected hands in those images, and we collected a set of a lot of images, 2 million images, that we annotated with all of the information that we actually needed to train a hand detection and a 3D reconstruction model. So we annotated with 2D key points, hand labels, so left or right hand, and also hand bounding boxes, 3D joints, and hand pose parameters. So we have something like this, where we have all of those data now to train both a hand detection model and a 3D reconstruction. So using those data, just by using those data, and a very, very simple model, a YOLO-based model, we were able to have very fast and very, very accurate hand detections. So although this model was very, very simple, it outperformed consistently all of the previous works in the field. And more importantly, as you can see in the video now, it was extremely fast, so it can run even on my CPU.
Sorry, can I get you to restart that video?
Yep.
Sorry, I didn't realize you were watching.
So this means that the whole pipeline is very, very fast now. I mean, we completely eliminate the detection part from the pipeline. Now in the actual 3D hand pose estimation, we relied on a large-scale pre-trained VAT backbone, and we divide this whole reconstruction in 2 steps. It is still a feed-forward method, but we divide it in first a rough hand pose estimation directly from the VAT backbone. So this is almost accurate, but not very accurate. And then we refine this estimation by projecting it into those VAT token features to refine the initial rough estimation. And what we get from this is very accurate performance. We outperform all previous methods in 3D hand pose estimation. And we can get very reliable reconstructions that outperform even the recent Some 3D body model from Meta. So in terms of hand reconstruction, we have now very accurate methods to reconstruct 3D hand poses. So from in the wild images, we can first detect and then reconstruct the hand poses in the 3D space. So you can see here even different hand scales, poses with occlusion, and also black and white images. But what is the most interesting is that although our method relies only on images, it is still very, very consistent in videos. So this, what you're going to see here, it doesn't have any temporal consistency module. But note that it's very temporally consistent without having any model for the temporal consistency. So now using this 3D reconstruction model, we can build our system to annotate sign language datasets. So what we developed throughout our works in CVPR 2025 and ICCV 2025, it's actually CVPR 2024, sorry. But what we did is we also took OSX, which is a 3D whole body pose estimation method, but it doesn't have that accurate hands. And we used Wheeler, the model that I presented earlier, to fix its hand poses and also the poses of the arm and the wrist. So now we were able to get very, very accurate 3D reconstructions for the whole body, for the whole upper body of sign language videos. As you can see in the next frame, in the next slide, we have all those 3D reconstructions with very accurate hands from different datasets. And of course, we provide all those publicly available in those QR codes. If you are interested, you can find our datasets and also the model to capture 3D hands. Thank you very much. And if you have any questions.
Thanks. Maybe you could respond.
Yeah.
Hey, thank you. That was really interesting. I'm just interested in do you say it was 2 million frames of data that you captured and labeled yourselves? Just interested in how you labeled it.
So we have a very engineered pipeline where we do an ensemble of multiple detections and reconstructions, and then we fit and refine them to ensure that they are accurate. So it's basically an ensemble network and then optimization. Thank you very much.